Alright guys, let's start lesson 4-2. It's called Patterns and Linear Functions. And our objectives would be to identify and represent patterns that describe linear functions. So sometimes we're going to have patterns that are going to come from pictures, and sometimes we're going to have patterns that are going to come from tables. And what we're going to try and do is see the relationship between the patterns and then ultimately the linear functions is what really makes this algebra. Okay, so starting off with a little bit of vocabulary. You might recognize this from science if you've gotten there yet. The dependent variable, that's the variable that changes in response to another variable. And I added this stuff on because this is going to help you a lot more later. When we talk about functions, the dependent variables are going to be the outputs. And when we start graphing them, these are going to be graphed on the y-axis. So dependent variable changes in response to another variable, and then independent variable, well, that's the variable that it's changing in response to. So those are going to be the inputs, and those are going to be graphed on the x-axis. So just to give you a real simple example, because I've always had trouble with independent and dependent variables. So the independent is going to go on the x-axis, so that's down here, and the dependent is going to go on the y-axis. Now, very often the independent variable, a lot of times, it would be something like time. So we could say like maybe years. So let's say maybe like 1 year, 2 years, 3 years, 4 years. What confuses a lot of people is that it says the dependent variable changes in response to another variable. Well, the independent variable also changes. It has to change because you can't just have 1 year and then graph everything about 1 year. So the independent variable also changes, but let's say our dependent variable was something like height. Like if you measure your height in feet, maybe, I guess when you're 1 and 2 and 3, that's pretty small. Maybe we would have to do inches maybe just because you're so small then, but the height is changing. So when you're 1, you're maybe like at a height like this, whatever that is. When you're 2, you're a little taller. When you're 3, maybe you have a growth spurt and you get a little taller. And then 4, maybe not as much of a growth spurt, but you get a little taller. So it's changing. Your height is changing in response to the time. But the time is also changing. So don't get confused. Don't say that the dependent variable is the one that changes. That's what I hear a lot of times when you come from science and you explain it to me. You say the one that changes. But the independent variable also changes. It's going like 1, 2, 3, 4, 5 years. So make sure when you say it, at least in the math sense, it's changing in response to another variable, and that other variable is your independent variable, which it could be, it doesn't matter. It could be 1, 2, 3, 4, it could be any years. Okay, so a lot of this chapter has to do with making patterns. So it says in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? So those are your two variables. Number of rectangles, which would just be 1, 2, 3, 4 so far, and the perimeter they form. So you have to decide which one's the independent variable and which one's the dependent variable. So when we make our table, anytime you make your table, your x is going to go on the left and your y is going to go on the right. So if you remember, your x is your independent. So which one do you think is independent and which one's changing based on that variables? So I'm going to make this a little bigger. So your x and your y. Your independent variable is the number of rectangles. Okay, and then what's changing in response to that is the perimeter. Okay, so your perimeter is your dependent variable, which goes on the y-axis. So we know for the table, the number of rectangles, we have 1 rectangle, 2 rectangles, 3 rectangles, 4 rectangles. Now it's pretty easy, we could just figure out the perimeter. So if the long side is 6 and the short side is 1, then if you look at this small rectangle, we have 6 on both sides and 1 and 1. So 6 plus 6 is 12, plus 2 more would be 14. Okay, then when we move on to 2 rectangles, we still have the 6 here and the 6 here, but we lose that middle 6 because you're only counting the perimeter. So it's still going to be 12, but then we have 1, 2, 3, 4 on the top. So 12 plus 4 would be 16. and then we still have the 6 and the 6, and then we have 1, 2, 3, 4, 5, 6 on the bottom. So 12 plus 6 would be 18, and you can kind of see a pattern. It's plus 2, plus 2, and we could check and make sure the picture matched, but again, it's still going to be plus 2, and this is going to be 20. Okay, so there's our table. Now, in words, how we're going to describe this is describe the perimeter based on the number of rectangles. Or you could describe it how the perimeter changes from one rectangle to 2 rectangles. So it's really easy to say that the perimeter each time you're just adding on 2, but it says what is the relationship between the number of rectangles, so from the number of rectangles to the perimeter, so from this to this. So if we go back and we say that instead of just saying 14, 16, 18, 20, let's just write down how we got those numbers. So it was always 2 times 6, right? Because we always had the two sides that were 6. And then we added on, now we had 1 here and then 1 here for the bottom. So we always had 2. We always had 1 on the top and 1 on the bottom. But then each time we picked up another rectangle, we multiplied it by 2 again. So this first one was 2 times 1 rectangle. The second one was 2 times 6 for the long sides, plus 2 because the top piece and the bottom piece, but you had that for each rectangle, so times 2. Then the third one was still 2 times 6, and then to pick up the top piece and the bottom piece, we had 2 for the top and the bottom, times 3 rectangles, and then the last one was 2 times 6 plus 2 times 4. So in words, what we're doing is multiplying 2 times 6. Oops, it's hard to write with this pen. 2 times 6 to get the lengths. Then adding on 2 times the number, 2 times the number of rectangles to add on the widths. Or something like that. I mean, you can explain this in words a lot differently, but explain exactly what you're doing. You're multiplying 2 times 6 to get the length, and then adding on 2 times the number of rectangles to add on the widths. Okay, the equation, once you have it written in words, it's really easy to make the equation. So your equation, now use x and y if you can, because our table is x and y, or you could use p in number of rectangles, but let's just use x and y. So to get the y, you always had 2 times 6, then you were adding on 2, and then this number right here from the table, 1, 2, 3, 4, those were your x values. So 2 times 6 plus 2x, which is really 12. 2 times 6 is 12 plus 2x. So that's your equation. Okay, then a graph, if we were going to make a graph, I'm going to just, but it's okay, we don't have to graph this one. But you would have, you'd have number of rectangles down here, because I'm pretty sure you guys can graph, and then perimeter up here, and you would have 1, 2, 3, 4. And I can't remember the numbers, but you would put the numbers up the side here, and then you would just graph them. But not very much of, I mean, this is probably the least important part. Least important part is making the graph, because I know you guys know how to make the graph. So making the table and then making the equation really are the most important. Okay, so let's try it with this picture. Let's do the table. Okay, so our independent variable is going to be the number of triangles. 2, 3, 4. So we have number of, I'm just going to draw a triangle. Okay, that's going to be our independent, so that's our x. And then our y is going to be the perimeter again. Okay, so we have 1 triangle, 2 triangles, 3 triangles, 4 triangles. Now, instead of just writing down the number, let's do the same thing we did last time. Try and figure out what's constant each time, and then what you're adding on based on, like, how is the perimeter changing in response to the number of triangles. So if I look at the pictures, I see that I have a 3 and a 3, and then on the next one I still have a 3 and a 3, and then on the next one I have a 3 and a 3, and the next one I have a 3 on a 3. So if this pattern continued, I would still have those two side pieces. So it seems like I'm always going to have a plus 6. So I'm just going to put plus 6, plus 6, plus 6 for all of them. Now, I also have, so for this first one I have a 4. Seems like this bottom piece is 4. But I only have one triangle, so I have 4 times 1. Now on the next one, when I have 2 triangles, I have 4 times 2. And then on the 3 triangles, I have 4 times 3. And then on 4 triangles, I have 4 times 4. If you can write it like that, it'll help you write it in words, and it will also help you write your equation. So let's figure out what the numbers are. 4 times 1 is 4, plus 6 would be 10. 4 times 2 is 8, plus 6 would be 14. 4 times 3 is 12, plus 6 would be 18. And 4 times 4 is 16. 16 plus 6 would be 22. Okay, so our perimeters are 10, 14, 18, and 22. But that's so easy. I mean, you could just add up the perimeters and get that. What we did before that is really what's going to help you write the equation. So, in words, I'm not going to write this one all out again, but it's the same thing. The perimeter is 4 times the number of triangles plus 6. Okay, so our equation is going to be y equals. Equations, when you have two variables, you have a dependent and independent. Your independent variable, your equation's always y equals, because the other one is changing in response to that. So how is it changing? It's going to be what it equals. So we have y equals, well, we always have 4, and then look, these values right here, this is what's changing. 1, 2, 3, 4. Those are your x values. So we have 4x plus 6. And then you could graph this, I mean, just like we graphed the other one. But like I said, the graphing really isn't that important. Okay, and then just a little bit more vocabulary. If you have a function, and that's what when we've been writing equations and functions are a lot the same. It's a relationship that pairs each input value with exactly one output value. So a function is a relationship that pairs each input value with exactly one output value. Your output values, those are your y values, and your input values, those are your x values. Okay, a linear function. Linear kind of looks like the word line. It actually has the word line in it. It's a function whose graph is a non-vertical line. It's really a function whose graph is a line, but the reason they say a non-vertical line, because if you have like an xy axis like this is linear because that's a straight line. This is linear because that's a straight line. If it's straight up and down like this, that's actually not linear. That's going to be something else that we'll learn about. So that's just why they say non-vertical. But as long as you remember that a linear function makes a straight line, that's all it is. And then this is a little picture I took from the book. It's called a function machine. You might have seen them maybe like in 6th grade. But you put an input value in. You do what the function says, which is a little bit of math, maybe like 3x plus 6. And then you come out with one number. Okay, so I'll show you with some, when we get in ordered pairs and stuff, I'll show you what makes something a function and what makes something not. Okay, so last piece here, it says the table shows the relationship between the number of photos you take, that's the independent variable, and the megabytes left on your camera chip. Okay, so that's the independent variable, this is the dependent variable. Okay, is the relationship linear? So describe the relationship using words, an equation, and a graph. So what's happening here is that when you have taken 0 photos, you have 512 megabytes left. After you've taken 1 photo, you're down to 509. After you've taken 2, you're down to 506, and after you've taken 3, you're down to 503. So what makes it a function is that each x value, so you have 0, that matches with 512. You have 1, that matches with 509. 2 matches with 506, and 3 matches with 503. If you would have another 3, and that would match with a different y value, maybe 502, that's what makes it not a function, because you can only have one x value for every y value. Okay, so it says it's a function, but then it says, is the relationship a linear function? Well, you could graph this and it would make a straight line. So, yes, it's a linear function. If you write an equation, you'll start to see what equations look like as linear functions. But for now, if you just see that each of these, if this is going up by 1 each time, and this is going down by 3 each time, yeah, minus 3, minus 3, minus 3. As long as these y values are changing by the same amount, you can imagine what it would look like on a graph. You have 1, 2, 3. Well, actually, you have 0, which is right here. 0, 1, 2, 3. And wherever it starts up here at 512, it starts right here, and then it goes down by 3, and then it goes down by 3. Oops, I did that wrong. It starts at 512, so it starts right here. Then it goes down by 3, goes down by 3, it goes down by 3. And this is going to make a perfectly straight line, which makes it a linear function. Okay, and that's all we have to do with that one. And last part, just try the lesson check on page 243. It's 5 questions. We'll start with that tomorrow in class just to see if you kind of got what we were talking about in this lesson here today. That's it.